Classmates, in our Network Fundamentals course, we have previously covered the IP protocol and IP addresses. Today, we will introduce the network mask, which corresponds to IP addresses in a network. First, let's review what the IP protocol is. The Internet Protocol, commonly known as IP, not only provides a unified data packet format for interconnected networks, but also offers addressing, routing selection, data segmentation, and reassembly capabilities. It can forward data packets from one network to another. IP data packets are referred to as IP datagrams on the Internet, and the IP protocol provides a reliable connectionless datagram service. It does not check the correctness of transmitted datagrams, does not send acknowledgements, and lacks flow control and error control functions. IP simply endeavors to deliver datagrams to their destination without any guarantees. If errors occur during the transmission due to noise, expired time to live, lost datagrams, circular routing, or invalid links, IP does not handle these situations. This characteristic is not a drawback. Instead, it provides a framework for data transmission, allowing users to add necessary functionalities at the transport layer based on their requirements, thus enabling TCP/IP to achieve maximum transmission efficiency. So, what is an IP address? An IP address, also known as the Internet Protocol address, is a unified addressing format provided by the IP protocol. It assigns a logical address to each host on the Internet. IP addresses are allocated by the Internet Corporation for Assigned Names and Numbers, ICANN. An IP address consists of two independent segments of information: the network number, netted, and the host number, hosted. Now, let's take a look at the format of an IP address. Currently, there are two commonly used types of IP addresses, IP4 and IP6. Today, we will focus on IP4. An IP4 address is a 32-bit binary number. In simple terms, it consists of 32 binary bits. It is usually represented in dotted decimal notation, where the IP address is divided into 4 groups of 8-bit binary numbers. Each group of 8 bits can also be represented by a decimal number, and these numbers are separated by dots. For example, our previous 32-bit binary 10101100000 10000011 1110101100 becomes the IP4 address 172.16.122.204. Alright, now that we have learned about IP addresses, let's move on to study network masks. The network mask, also known as the subnet mask or address mask, is a 32-bit address used to mask a portion of the IP address to distinguish the network number and the host number. In the network mask, a continuous sequence of binary digits, 1 starting from the left side, indicates how many bits of the IP address belong to the network number, while the remaining binary digits, 0, represent the host bits. In the diagram, the 1s in the network mask correspond to the network bits of the 32-bit binary IP address, while the 0s correspond to the host bits. Just like IP addresses, we usually represent network masks in dotted decimal notation, converting the 32-bit binary into 4 decimal numbers. Additionally, we can use prefix notation to represent network masks. In this notation, we append a symbol followed by a number from 1 to 32 after the IP address. This number represents the length of the network identifier in the network mask, which is the count of 1s in the network mask. For example, 192.168.1.120. Here, 20 indicates that the network mask has 20 continuous 1s followed by 12 continuous 0s. In decimal notation, this becomes 255.255.240.0. Finally, let's take a look at the purpose of the network mask. The network mask is primarily used to determine whether hosts on a network are in the same subnet. The calculation method involves performing a bitwise AND operation between the host's IP address and the network mask, resulting in the network address. If two IP addresses have the same network address, it means they are on the same network. And if they are on the same local area network, LAN, they can communicate directly. For example, with a network mask of 255.255.0.0, let's consider two hosts. Host A with an IP address of 192.168.10.1. After the AND operation with the network mask, we get the network address as 192.168.0.0. Host B with an IP address of 192.168.20.128. After the AND operation with the network mask, we get the same network address as host A. Herein, both host A and host B are in the same subnet. The above is the content of our lesson today. Through this learning, we have understood what a network mask is and its purpose. Now, I would like everyone to complete the following assignment. Calculation question: determine whether the following two IP addresses are in the same network. 192.168.240.520 and 192.168.238.1120. All right, that concludes today's lesson.